to the left. When you look up, remember your z-score table? When you look up your area, it's always to the left of that number. This entire curve represents 100%. Or because you use a decimal chart, the whole area is equal to 1. Whenever we locate a score, such as 1.15, somewhere over here is 1.15. Somewhere. We want to look up the area that corresponds to this z-score. The area that we look up is to the left of it. So, first thing your eye sees is it more than half of your curve or less than half of your curve? It's more than half of my curve. So when I look this up, I have to find a number that's greater than 50%. This is what's going to help you if you forget to subtract it from 1. So, we find your table, and I gave you copies of it again. And in the book, it goes through how to find your z-score. If you take a look at the page 220, down the left-hand side, you're looking for 1.1. Across the top, you're looking for 0.05. This is the last digit. This is the hundredth digit. So in other words, if I added this to 0.05, I get this. The one across the top is like money, is like your penny. This is like your nickel out here. So you're looking for your penny out there. So 1.1, follow your chart in the book on page 220. 1.1, go along to 0.05, and they find it. And your area under your curve, you'll see. Did you find it? So what is your area under your curve?
0.8749.
Okay, 0.8749. Did everybody find this? I gave you a copy of the chart Tuesday. This is going to be a killer with the Monday, Tuesday thing. The last day we met, like Dr. I says, the last day we met, I gave you a copy of your chart. Now, if this is greater than 50%, I know I'm on the right track. If this said, find the area to the right of 1.15, then we want this little area right here. Could that be larger than 50%? No. So when I look up this score in my table and I get this large number, what should I do? Subtract it from 1. So anything to the right, I want to subtract from 1. Yes.
So, on the question, will it say specifically
to the left, to the right?
Okay.
If it doesn't say, it's always to the left. And guys, Darian has a good point. If it doesn't say, then it's to the left. If it says to the right, then we're going to do the 1 minus. But if you put this in perspective and you say, this area is small, it cannot be this one. So like Taylor said, subtract it from 1. Your whole area is equal to 1, or 100%. This is still a percent. I could flip this and say 87.5% of my curve is covered. Okay, we're going to put this to a scenario as soon as we get used to doing your scores. So now say I want to find a z-score of negative 0.24. Between which two numbers would I find that?
Oh, negative 1 and 0.
Negative 1 and 0. Good. This is like a number line. Where does the negative come? On this side. This is negative 1, so not quite there. So probably about here, negative 0.24. I want the area, cumulative area means to the left. This is to the left. I want this area to the left. By eyeballing this, and I always make you make a sketch of these things because the sketches is what's going to help you. Is it greater than 50% or less than 50%? Less. So the number when I look it up to the left should be less than 50%. So how would I look up this number? What am I going to look up on the left-hand side? Negative 0.2. And what am I going to look up on the top? 0.04. So everybody find me that area. This is your tens place that you're looking up, and sometimes you have a number next to it, 1.2. So find me that area.
3.04.
No. 0.4052. Make sure you're on the negative side. There's a positive side and a negative side. So does that seem reasonable? This is kind of like close to 50. I'm kind of close to halfway, right? I'm a little less than halfway, so that's reasonable to me. If I said the area to the right instead of cumulative, if I said to the right of negative 0.24, what would you then do? Subtract it from 1. And that should be greater than 50%, right? Because that's the greater than 50% part that I would need. Good? The sketch helps tremendously when you do this. Okay? Let's have you guys try one. Okay? You're going to find the area under your curve for these two things. We don't need any percent here anymore because what we do is we look it up in your table. So we don't need any percent. I want you to find the area to the left of this number and the area to the left of this number. Remember, we're dealing with a normal curve. The cumulative area, everything adds up to 1. We go as low as negative 3.49, as high as 3.49. We can go higher, but they're negligible after that point. It's symmetric about the 0. It has all the attributes of your standard normal and your normal. The best way to do is locate these first. Where does negative 2.19 fall between? Which two integers?
Negative 1 and negative 2.
No.
Negative 2 and 3.
Negative 2 and negative 3. See it? It doesn't quite get to the 2. Where does 2.17 fall between? 2 and 3. Guys, whenever they ask for cumulative or area to the left, that's what your table gives you. When you look at this one, should this be a small number or a large number for the negative 2.19? Small. So Taylor, what'd you get?
0.0143.
Okay, did everybody get that?
Yeah.
Anybody not get that? And it makes sense, doesn't it? It's a very small part of my curve. Remember, the bulk of your curve sits in the middle here, sits right through here. That's the biggest part of your curve. The ends, even though we draw them so that you can see them and it looks like it's got a little area, it has very small area out there. So it's just a little bit more than 1% of your curve that covers. Your bulk of your area falls in the middle. Okay, so how about the score of 2.17? 0.9850?
Yeah.
Good? Everybody agree with that?
Yeah.
And does that make sense?
Yeah.
To the left, look how much this covers. I have very, very little to the right. Remember, plus or minus 2 is about 95%. Plus or minus 2 would be in here, agree, but this little piece here would probably take up the slack there. So you got to figure somewhere over 90%. That's a big chunk of your curve. Yeah, it is small going here, but this is a little small section left here. If I wanted to find the area to the right, I would just take this and subtract it from 1. and that would, because my entire area has to equal 1. Questions? Anybody not able to find this? Well, this is important. Do you remember when we did this? We did this kind of before the probabilities. They introduce it first, and then they introduce probabilities, and then they come back to this. Now, there's 3 things that you're going to have to do. One is the area to the left, and I think I have this on your note page. When you look up the area to the left, you look it up in your table, and you use that area. One is the area to the right. This is when you subtract it from 1. Sometimes we have to find the area in between 2 scores. So if I did this, in between 1.5 and negative 1.5. Now, watch what happens here. Watch. When I look up negative 1.5, I get this area right here. Can anybody look this up in the table and tell me what this area is, please? Negative 1.5. Point what?
0.668.
Negative 1.5? What do you get? Anybody got it?
146.
Okay. Now, watch. When I lift this area up, it's the area to the left again. So can somebody look up 1.5?
Got it, miss.
Thank you, mister.
Miss Moore. 0.9332.
0.9.
332.
332?
Did it right.
Yeah,
They're both equal to 1.
Okay. Now, watch. This area is to the left. This area is to the left. Do you see where they overlapped right here? I only want the squares in between. All I want is this piece right here. Ah, so I subtract. Good job. I take these areas and I subtract the areas. Not the z-scores, just the areas. So if you subtract the areas, you find the area in between.
0.8664.
Thank you, Gunnar. 0.8664. Now, I want you to think for a second.
Since you're a mathematician, Leonard. Thanks, Aaron.
Okay, listen, guys, think for a second. Plus or minus 1 was about 68%. Plus or minus 2 is about 95%. We just did plus or minus 1.5.
About.
So shouldn't it fall in between there somewhere, right?
Let's say approximately 86.64%.
Very good
Wow.
approximation,
Wow.
Joe.
I really got to be
Very
right on
good.
the
Very good. That was an excellent approximation. So, are we feeling this? Good. Okay. All right. So let's work with this chart and find a couple more. Guys, I want the area, and for some odd reason, they're both look exactly the same. Shouldn't. Okay, let's find this area to the left of this number, to the right of this number, and in between. So, if I have 1.23, between what 2 integers does this number fall? 1 and 2. So I'm somewhere right here. I want the area to the left. Should it be larger than 50% or less than 50%?
Larger.
Larger. So let's look it up on your table and find me the area to the left.
0.89.
Thank you.
Oh, one type of there.
Okay. Say I want the area to the right. This little area. What should I do?
Subtract by
Subtract it
1.
from 1 because the total area under the curve equals what? 1. That's one of our attributes.
Oh, I see what we're doing here.
Okay? So subtract it from 1. What do you get?
1093.
Thank you. Put 1093. Okay. This one's a little different. I want the area. I want it quiet first. And then I want the area between negative 0.75, between what two integers does negative 0.75 fall?
0 and then
Good. Right here.
You want that?
That's the area to the left. And where does 1.23 fall? In between 1 and 2. And didn't we find that area already? We know that area to the left. And what are we going to have to do when we find those two areas?
Oh, I know what it is.
Subtract them.
60.
So we've got this one.
Well, my level of confidence.
All we need is this. Find me this one. Negative 0.75. Should that be less than 50% or more than 50%?
more. Less.
Less. It's below the 0, so it has to be less.
2266. Oh,
0.2266.
I got that answer.
Thank you.
Yeah.
Now what do we do?
That was definitely like
Subtract them.
something.
0.2206 or 66? Okay. So
You guys
that's the area in between. Does it make sense?
Yeah.
Okay. So far so good.
At least on
The
the
easy
board.
part. And then
What?
the
That
second
is-
thing.
All right.
answers 1 and 2 are